Determine if the series converges or diverges. We have the sum from n equals 1 to infinity of negative 1 to the power of n times 7 to the power of 2n plus 1, all divided by 2n plus 1 factorial. Because of the factorial, we'll be using the ratio test shown on the right. We're given the sum from n equals 1 to infinity of a sub n, with the limit as n approaches infinity of the absolute value of a sub n plus 1 divided by a sub n equals L. If the value of the limit L is less than 1, then the series converges. If the value of L is greater than 1 or approaches infinity, the series diverges. And if L equals 1, the test is inconclusive. Let's begin by determining a sub n plus 1 and a sub n. Because we're taking the absolute value of this quotient, we'll just leave off the negative 1 to the power of n. Everything else is already positive. So a sub n is 7 to the power of 2n plus 1 divided by 2n plus 1 factorial, which again is always positive. And now to find a sub n plus 1, we substitute n plus 1 for n. Again, this is always positive. Simplifying, we have a sub n plus 1 equals 7 to the power of 2n plus 3 divided by 2n plus 3 factorial. And now let's go ahead and set up the limit, where again we have the limit as n approaches infinity of a sub n plus 1 divided by a sub n. And again, no absolute value is required because everything is positive. And now let's write this complex fraction as a product by multiplying the fraction on top by the reciprocal of the fraction on the bottom. And now we need to begin to simplify. Looking at the factors of 7, notice 7 to the power of 2n plus 3 has two more factors of 7 than 7 to the power of 2n plus 1, leaving us with two factors of 7 in the numerator. And if we expand 2n plus 3 factorial, remember 2n plus 3 factorial is equal to 2n plus 3 times 2n plus 2 times 2n plus 1 and so on. The factors of 2n plus 1 and so on equal 2n plus 1 factorial. And therefore the denominator simplifies to 2n plus 3 times 2n plus 2. This gives us the limit as n approaches infinity of 7 squared divided by the product of 2n plus 3 and 2n plus 2. Just in case you want to see more work on how I simplified this, let's go to the next slide and then we'll come back. Again, to simplify 7 to the power of 2n plus 3 divided by 7 to the power of 2n plus 1, we can write 7 to the power of 2n plus 3 as 7 squared times 7 to the power of 2n plus 1. Remember, when multiplying and the base are the same, we add the exponents. 2 plus 2n plus 1 is still 2n plus 3. In this form, 7 to the power of 2n plus 1 divided by itself simplifies to 1, leaving us with 7 squared in the numerator. And then simplifying the factorials below, if we expand 2n plus 3 factorial, again that's equal to 2n plus 3 times 2n plus 2 times 2n plus 1 times 2n times 2n minus 1 and so on. Notice all the factors from 2n plus 1 on are the same factors as 2n plus 1 factorial, so all these factors simplify out, and again, we're left with 2n plus 3 and 2n plus 2 in the denominator. And now going back to our limit. Now to determine the limit, let's go ahead and square 7 and multiply out the denominator. Notice as n approaches infinity, the denominator increases without bound, and therefore the values of the fractions get smaller and smaller and approach 0. And because 0 is less than 1, we know the series converges. In conclusion, by the ratio test, since L equals 0, which is less than 1, the infinite series converges.